For this lesson, we're going to look at how we find solutions and whether an ordered pair is a solution to a given system. So you're going to be given an ordered pair as a possible solution, and you want to ask yourself, is this where the two lines cross? So remember, in an ordered pair, you've been given an x value and a y value, and we're going to substitute each of those values into the x and the y and see if it makes a true statement. To make this a little bit easier on ourselves, I'm going to call the first equation equation A and the second equation equation B, just to be a little more organized. So I'm going to take equation A there, and I'm going to replace the x with a 2, then subtract the 4, and I get, we want to see, does that equal negative 12 or negative 2? So is this a true statement? And we can see that 2 minus 4, so 2 minus 4 is indeed negative 2. So this is, okay, this is a solution for A. Now let's try equation B, which is the second one. So for equation B, once again, where the x is, so I get 2 times 2 for the x, plus 4 for the y. We want to know, and I'm putting a question mark because I don't know if that's true yet. Is that true? So 2 times 2 is 4, plus 4, does that equal 8? And yes, that's true. So is this a solution? Yes, it is. For an ordered pair to be the solution to a system, it must be true for both equations. Once it fails for one of the two equations, it is not a solution for the system. So let's see if the next example is a solution. So this time we're going to use negative 1, 4. Going to go a little bit faster. We've got x and y. I'm going to label my equations, the top one A and the bottom one is B. So for the top equation, I'm going to take A right here. I'm going to replace the x with the negative 1. I'm going to add that to 2 times the 4. And I want to know, question mark, is that equal to 6? So I've got negative 2 here, plus 8, does that equal 6? And it does, so we can stop right there. For equation B, do the same thing. So 2 times that negative 1 plus 4. I want to know, is this equal to 6? And I've got negative 2 plus 4, and that does not equal negative 6. So this is not a solution. It failed one of the equations. Just a quick note, if it does fail A, there is no reason to go ahead and check B. Now we're going to move on to how to find solutions, and one method for that is to graph your two equations. So the first thing you want to do is kind of take a look at your equations and figure out how you're going to graph those. So this first one is y equals x plus 3. So, and this is y equals negative 2x plus 6. So both of these are in slope-intercept form, which means we can find the slope and the y-intercept quite easily. So just to label these, I'm going to call this first one equation A, and I'm just going to identify the slope, which there's that hidden 1 in front of that x. So my slope's going to be 1 over 1, and my y-intercept is 3. I'm going to go to my graph, put a point at 3, rise 1, run 1, rise 1, run 1, rise 1, run 1 a few times, and then take a ruler or a straight edge to make as straight a line as possible. And finally, we're going to graph equation B. So I'm just going to identify my slope, which is negative 2. I'm going to put that over 1, so I have a ratio. my y-intercept is 6. So I'm going to go up to 6, put a point. I'm going to drop down 1, 2, run 1, drop down 1, 2, run 1. A little bit off there, but hopefully you can see what I'm doing. Take a straight edge or a ruler, try to draw that line as straight as possible. I can see that my two lines cross right here at that point, and it looks like the x value of that point is 1, and I've scribbled quite a bit, so it's a little hard to see, but it looks, I'm pretty sure that that y value is 1. So here's the thing, is I really want to check my solution to make sure that it is, because it's hard to see on a graph if that really is the correct point. So to check it, we do what we did in the previous example, and we're going to substitute the 1 and the 4 in for x and y into my two equations. So equation A, the y is 4. That's going to equal the 1 plus 3. Is that true? Yes. Equation A checks out. You can also just do this mentally. It's a very easy check to make. So for equation B, it looks like my y value is 4. I've got -2 times 1 plus 6. Is that, let's see, -2 plus 6, does that equal 4? Yes, it does. So it does check out. Very easy to check your solution to make sure you do have the right solution point. Example B is in standard form, which, if you remember, is the ax plus by equals c. The best way to graph when you're in standard form is to first let your x equal 0. So we're going to do this for equation A. I've got, let's see, so when x equals 0, that x is just going to cancel out. I'm left with -y equals -5. So that's a 1 there. I can divide both sides by the -1, and we get y equals 5. So that's going to give me an ordered pair of 0, 5 to graph. That's my y-intercept. Then I'm going to let y equal 0. When I do that, this y term goes away, and I'm left with just x equals -5, easy peasy. So my ordered pair is -5, 0. And take my ruler or straight edge and draw a line through those 2 points. What I'd like is for you to try to graph the next equation on your own and see if you can come up with the solution for this system. All right, it looks like when I cross these that my solution is at -4, 1. Kind of a coincidence that we had a 1 and a 4 in our previous answer, but just a coincidence. So let's check it though, because it's always hard to tell on a graph if that's true. So let's substitute our values into equation A. I've got -4 for the x, -1 for the y. We want to see, does that equal -5? -4 minus 1 does equal -5. So that looks good. For part B, we've got 2 times that -4, which is the x, plus 4 times that 1. We want to see if that equals -4. So I've got -8 plus +4 equals -4, and that is true. So definitely -4, 1 is the solution for this system.